In this video, I will be testing the GD-2 thermal paste, which is one of the compounds sold by the famous Chinese thermal paste manufacturer GD brand. The paste is available in various formats, ranging from 1 gram syringes to 30 gram syringes and even a 150 grams pot. The sample I tested came in a 30 grams tube, which included a spatula and 2 finger cots. According to the manufacturer, the GD-2 thermal paste has a thermal conductivity of 7.5 watt per meter by Kelvin, a density of 2,500 kilograms per cubic meter, and an operating temperature range of -50 degrees Celsius to +120 degrees Celsius. This means that in an extreme overclocking scenario, it is suitable for use even with dry ice or a single stage unit. When it comes to using the product, simply apply the thermal paste onto the processor's integrated heat spreader, IHS, using your preferred method, with an X pattern being used here. Unlike the more watery consistency of the GD-900, the GD-2 is much more viscous and can be slightly challenging to spread evenly in some cases. It's worth noting that the GD-2 is non-conductive. The purpose of the review is to evaluate the performance of the GD-2 and compare it to other thermal interface alternatives that have been previously tested. In these tests was used the Ryzen 7 2700X with the settings you can see on the screen. We used Blender to render the classroom demo for 30 minutes to obtain the results. We tested the thermal paste immediately after application and cooling assembly and again in the next day, after a few heat-cool cycles, alternating between 40 minutes of idle and 40 minutes of stress in IETA. The idea is to verify whether the thermal paste has any curing time or if there is a difference in performance between the freshly applied product and the one that has undergone some thermal cycles. It's worth noting that this article's focus is on testing the thermal solution's performance. It would be highly valuable to evaluate how these solutions perform after multiple thermal cycles to gain a better understanding of their durability after application. However, conducting such tests would be relatively expensive, requiring a fixed bench to be occupied for a considerable period or the development of specialized equipment. Therefore, for the time being, we won't be able to carry out these tests. In terms of performance, the GD-2 is certainly an upgrade from the GD-900-1, thanks to its superior thermal conductivity. In fact, the GD-2 demonstrated a performance advantage of between 2.5 degrees Celsius and 3 degrees Celsius over GD-900-1. What's more, this extra performance put it in the same league as the Thermal Grizzly Cryonet and the Thermalright TF7, which is an impressive feat. Another great advantage of the GD-2 is that it showed no change in performance even after a few thermal cycles, which is the known curing time required for some thermal pastes to achieve optimal performance. In conclusion, the GD-2 performed exceptionally well in the tests, securing the third spot in the comparison and outperforming its famous predecessor, the GD-900-1. It also performed closely with products such as the Thermal Grizzly Cryonet. Furthermore, it maintained its excellent thermal performance even after some curing time, which is a great. The cost of the GD-2 is also worth mentioning, as a 30 grams tube can be purchased from the manufacturer's official store on AliExpress for around $8.30, representing an excellent cost-benefit ratio when considering the performance demonstrated in the tests and the generous amount of product for the price. The only unknown factor is the long-term durability of the product after application, but based solely on its performance, the GD-2 is definitely recommended.